Hi guys, the next step in our compiler project will be to support conditional statements, if statements and loops, and for that we need some preparation. For example, we have to support in our code generation interface jump instructions, conditional jump instructions, unconditional jump instructions. We have to be able to generate unique labels, generate code for label definitions, and so on. And in this video I want to show you how to make these extensions and how to test them. The requirements for the code generation interface and also the test for these new features will be to generate assembly code for simple logical expressions like here where I want to compare two values for equality. If we have equality, the value of this expression should be 1 and otherwise 0. Now let's consider the assembly code that we need to generate for that. There are actually two possibilities. Both begin by loading the value of this variable x in this case into some register, let's say register 6. Then we would subtract from this register the value 42, store the result in the 0 register, because we are only interested in the status flags. And then afterwards we have choices. The first choice would be to check whether the 0 flag is set. In this case we could jump forward to an instruction that loads the value 1 into register 6. And otherwise we would continue after this conditional jump with some instruction that loads the value 0 into this register, and then we have an unconditional jump to the end of this construct. The second variant would be as follows. We begin as before, but then we check whether the 0 flag is not set. And in this case, we would jump forward to an instruction that loads the value 0 into the register 6. And otherwise, if the 0 flag is actually set, we would continue after this conditional jump instruction with an instruction that loads the value 1 into register 6, and then again we would have this unconditional jump instruction. So these are the two variants that we already used frequently in the past. So what should the code generation interface provide? There should be one function for generating a new unique label and another function for printing a label definition so that we can mark instructions with these labels. Then we also should hide certain details of the architecture, for example, the existence of the 0 register. There should be a function for comparing an immediate value with a register and another function for comparing two registers. Then we also should hide the details of the status flags. There should be one function for generating a jump instruction that jumps forward if equality is true, and it also should be possible to jump forward if equality is false, if we have an inequality. And then, of course, it also should be possible to generate an unconditional jump instruction to a label. Okay, so now let's begin to implement this. So, of course, we begin with the test program and include the usual things, standard I/O and the header for the code generation interface. And also finalize, and this should do it for now. If we want to actually have this example with the variables, then we also would need the symbol table header file. Okay, then let's begin with generating some unique labels. That's probably the easiest part. Let's generate 3 labels. And let's declare it here after setting the output for the code generation. So this simply returns a pointer to a character, and the idea for the name is that it's similar to get a new register. And then we check for typos, and then we can begin with the implementation for that. So first I turn this into a stub. And now we already can generate an executable with some warning. And there will be one variable for one global variable for the next identifier. The identifier will be generated by printing some string into some buffer. For that I use this allocate string printf function, and the labels will always have the form .l followed by some unique ID. If allocate string printf was successful, then we will not get back a null pointer. That means here we have the usual pattern, checking whether it's the null pointer, in this case the usual error message, and finalize exit 1. And otherwise we have in buffer some string that will be used for the label, and we will store this string in our unique strings list. And then we can release this buffer again and return the pointer to the first character. Okay, and that's already it. So for free, we also have to include standard lib and unique strings. Now let's see if this works. Okay, fine. And now we also need some function for printing the label definition. So that means I have to set the output first, and then the idea will be, for the example, I need 2 labels. A label for the instruction where I load the value 1 into a register, and a label for the end of this construct. And then I want to print this label definitions. And then I first want to test this here, so this is no longer needed. Before I continue, so let's put everything related to label definition and jump instructions here. And then again the test whether we have a typo. No, just a linker error. So that means now I can do the implementation. And basically I already have everything here. I have here a function for printing a label definition, but currently this is a static function and I want to keep it like that. I simply call this function, this print label definition function here. I don't want to rename things. Okay, now this should work. Okay, so this was the simplest part. Now we somehow have to set up this example for a logical expression. So I need one register for that. And here the instruction for loading 1 into this register. And before that, I load 0 into this register. And here I want to have this unconditional jump. Let's begin with that. So that means this is a new function. And then again, first checking for typos. then the implementation, and this simply prints out the jump instruction and the label followed by a new line. Okay. Now here my current print label instruction is actually doing more than just printing a label. I needed that for this word operators. And now I want to have a simpler print label function where I just print a label. So I simply call from here this former print label function with 2 0 pointers. And then I have to make sure that in the rest of the source file, this calls to this extended versions are now changed. So simply adding everywhere an underscore in this previous function calls, not here. And now this also should work now. Okay, this is a warning because I haven't released this register, so let's do things right. Okay, now we have a almost complete example. Then I want to have here this instruction for comparing two values, an immediate value with a register, and then I want to have this conditional jump after that. With that I will deal later. First I want to have actually two ways to compare values, immediate value with register and register with register. So let's also allocate another register 0. And then we also have to release this so that we do not get again this warning. Okay, so this means that I have here another toAddress instruction where the first operand is a immediate value and I need another group for this operators. And actually here this grouping is not done correct. So this needs to be changed anyway. So this is now the correct pattern for grouping these enum constants. So this is also kind of a code review for fixing such things. Okay. Now the implementation of this. And then I first have to fix the implementation of this toAddress instruction with two registers. So here I basically can copy this part and modify it. So this becomes an else if, and then here this compare register operation, where here I have this register 1, and after that the 0 register. And now the 0 register is hidden behind this interface. And then for this variant with an immediate value, I basically can reuse the part here. Let's move this up. Here I have to check whether I'm in the correct group. And here I'm not having an unary minus actually. This is done by constant folding, the unary minus for immediates. And here I have a value. Okay, and now we have this comparison of values in both forms. Now let's consider the conditional jump instruction. Here I simply want to have one enum constant for the equality condition and then a label to where I want to jump if we have an equality. And actually I will have two enum constants, another for not equal. So that means we have another group, and this time I should apply this pattern for grouping things correctly. So in this group we have this equal, and later I can add not equal after that. And then the declaration for this generate conditional jump. And here I also have a gen op enum. And then again, first checking whether I have some typos. And then the implementation of this. And here I can modify this assertion for checking whether I'm in the correct group. So this becomes cont jump, and also here. And then I also should check whether this is actually a non-null pointer, and then I can generate code for these two cases. And of course, this later can be extended for other conditions. Conditions like greater, equal, and so on. And if we forgot something, we get an assertion failure. And then I simply generate instructions for this conditional jumps that are used internally. And in both cases, we jump to this label. So print label and print new line here. Okay. Now let's see. Okay. And also working. At least the jump equal case. Now let's change this into an example where I can test both variants. In this first block, I want to generate code for this first variant, and in a second block, the second variant. So far, we don't have a function for generating comments in the assembly code, so let's do it this way. And this will not be printed into the assembly file, but for now it's good enough to see that this is the first variant for which we generate code. And now let's move this up. I can copy this and generate code for the second variant, where we jump forward if we have an inequality. And we jump forward to an instruction loading the 0 into a register. So that means we will change this into load 0. And this should be the condition not equal. And then we test both conditions. Yeah, so jump not equal in the second variant and jump equal in the first. Okay, and now I want to change the interface so that basically I can jump forward if the condition is true or false in both cases. And I realized that by changing the interface so that you can specify two labels for this conditional jumps, a true label and a false label, but only one of them is allowed to be different from the 0 pointer. And from that I can see whether the jump should happen in the case of true or the case of false. And that means I simply first replace here the declaration, and here I'm checking whether one of these labels is given, provided, and then I'm also checking that at least one of them is not provided. So this is basically a logical exclusive OR. And if the true label is provided, then we actually use a jump equal instruction and otherwise a jump not equal instruction. And if the condition is not equal, then we simply swap this. And then we print the label true label if the true label was provided and otherwise the false label. Okay. And now we basically have this abstraction that we can jump forward whether a condition is true or false. So same as before. I just don't have to invert the condition in my code for the interface. And now I want to turn this into a working assembly program, an assembly program that can be translated into an executable. So that means I have to print the header and the footer, and actually here I don't want to use variables. I want to keep it simple here, but I want to make it possible to read in some value from the user. So I use our input hack. I read some value into register 1, and then I want to print out the value of register 1, which should then be 0 or 1. And the same here, of course. Okay, now. Okay, so let's see. Okay, let's simply check whether this is working. A bit too much to go through line by line. If it works, then I simply assume that it's working. Okay, so let's use some alias for the assembler and the virtual machine. And then I have to also specify the assembly code for this print functions, of course, like in the last session. Okay, then we should have an executable. And if I type in 42, then correctly I get 1, 1. And in this case, 0, 0. So seems to work. That's it for this video. Now in exercise, you can extend this code generation interface for supporting more conditional jump instructions.